we're about 1 degree north of the equator and about to head into the southern hemisphere. So I thought that we'd take this opportunity to explore how exactly do you use a magnetic dipping needle? Well, the example that we have here has kindly been lent to us by the Royal Cornwall Polytechnic Society down in Falmouth. It's been in the basement of this institution for about 130 years, and so as a result the magnetic integrity of the needle has been preserved and it still works with a reasonable degree of accuracy. Built between 1841 and 1845 by instrument maker William George to the designs of Robert Weir Fox, the instrument is still just about measuring the Earth's magnetic field. So, how do you go about taking readings? How do you go about performing a magnetic experiment? Well, the most important thing to measure is the Earth's dip, the angle at which the Earth's magnetic field is acting upon the needle. To do this, Fox equipped his experimentalists with one of these. It's actually unfortunately made of ivory, but what you do with this is you apply it to a pin on the back of the needle, you scrape it a little bit, which causes the needle to oscillate, vibrate, also removes static electricity. You position the needle, you aim the north end of the needle towards the magnetic north pole, and then you use this here to read off the degrees deflection caused. We're actually, as we are so close to the equator, the needle is currently almost exactly on 0 degrees, which is phenomenally exciting. At the equator, the needle should be reading about 0 degrees, and then as we move further north, reaching the magnetic north pole, it should come up to about 90 degrees, which means that the magnetic poles and the equator are probably the two most interesting places to be using this needle on Earth. You can also, Robert Weir Fox also equipped the practitioners of this instrument with a series of magnetic deflectors. Now what these do is they allow you to also calculate the intensity of the Earth's magnetic field. So it's not just that we want to know the angle at which the magnetism is operating, we also want to know how strong the Earth's magnetic field is operating on the needle. And theoretically this should deteriorate the further away we get from the North Pole. With these deflecting rods, you screw them into the back at a fixed angle from the point of dip, the point of deflection, and then you measure how much impact the magnets are having on the needle. As we get further away from the North Pole, these magnets will have more influence on the needle as the Earth's magnetic field de-intensifies. There's also a series of weights, which we'll look at later on, for measuring the magnetic intensity by applying grains of weight. Altogether, this collection of practices enables an unprecedented range of skills and combinations for investigating the Earth's magnetic field, which I think really is why these instruments secured the reputation that they did with ships' crews. Anyway, over the next few days we'll be performing measurements with these into the southern hemisphere, and then it's on to St. Helena.